Okay, with this first problem, it looks like we need the distributive property, and we also need to be able to collect our like terms. Now, with the distributive property, that means I need to take A and I need to multiply it to each part. And when I do that, I have 4A minus A times A is A squared. You add your exponents here. And then you take this negative 5 and you also distribute through. And when you do that, you get negative 5A, and then you also get negative 35. Now we're going to collect our like terms, and looking at this, there's nothing that we can put with negative A squared. So I have negative A squared, and I would stop here and go look at my answers. And I would toss out anything that does not have negative A squared. And then notice our two answer choices really comes down to noticing, do I have negative 35 or positive 7? So when I go through and I start collecting my like terms, then I would just notice, well, what's going to generate that negative 35 here, or a positive 7, which would be that last number. So that's going to give me answer choice C. Now, if you wanted to finish the problem, you could. Notice that you have a positive 4A and a negative 5A, so that's going to leave you with a negative A and then minus 35. So that's to finish out the problem, but do remember that this is a time test and you might not have the luxury of all of the time that you might need to do this problem. Okay, for the next problem, you're looking at these from least to greatest, and notice they threw in 1/4 here. Now I would go ahead and say, well, I know 1/4 is exactly the same thing as a quarter, or 0.25. And notice if we're going least to greatest, the smallest number we have here is 0.03. So I would toss out everything that does not have 0.03 first. And then notice 0.25 being compared to 0.2. So now we have to decide, well, which of those two would be smaller. And notice 0.2 is definitely smaller than 0.25. So my answer choice should be G. Okay, moving on to number 3. Now number 3, we need to figure out, well, what is x squared minus 4? And this one, a lot of times people really rack their brains over trying to solve for x and then replug in. And that's not really necessary here. Let's take our x squared plus 4 equals 29. And we see very quickly that x squared has to be equal to 25. And that's all I would do with it, because what we're solving is x squared minus 4. Well, x squared is 25, and 25 minus 4 is 21. So the right answer choice there should be C. Now moving on to number 4, we have the vertices of a rectangle, and we have at -1, 2, so I have -1, -2, so here. And let's see, we have 4, -2, so go to the right, 4, and then down 2, and then 4, 3, 1, 2, 3, and also -1, 3. And so here's our rectangle. And let's see, what does it want us to do with this rectangle? When the rectangle is graphed in standard position, what percent of the total area lies in quadrant 3? So a quick review here, and they already have these numbered for you. So it's talking about in quadrant 3. And notice we have 2 of our squares in quadrant 3. So if we knew how many total squares we have, that would be great. So let's count off. We have 1, 2, 3, 4, 5. And then we have 1, 2, 3, 4, 5. So we really have 2 over 25. And so very quickly we can type that in our calculators, and we see that we get 2 divided by 25 is 0.08. And then what percent is that? Well, we need to take 0.08 and multiply by 100. And notice that's going to move our decimal 2 places to the right. And so that's going to give us answer choice F. Okay, with this problem, we're told that in 1985, the cost of clothing for a certain family was $620. And then we're told in 1995, 10 years later, the cost of clothing for this family was $1,000. And assuming the cost increased linearly, what is the cost of the family's clothing in 1991? So a couple of ways you could think about this. We could think of 1985, that's our starting point. And so really we have an ordered pair here. We could think of this as points. And 1985 is our starting point, and our cost was $620. And then over 10 years, so I have 10, the cost of the family's clothing was $1,000. So we could see what the rate of change of this is. Very quickly, we could do our slope formula, which is y2 minus y1. So I would have 1,000 minus 620, which is their change over the past 10 years. So what is that going to give us? And we could go ahead and figure out what that's going to be on our calculators. Let's see. We're going to have 1,000 minus 620 is going to be 380 over 10. So that's going to give us 38. Now, what are we going to do with this 38? What does that mean that we're increasing or changing by? So here, let's see. Goodness, well, we've got 38. That's how much it's changing every year. So I need to take that 38, which is how it changed over those 10 years. And notice that I'm going to say, well, how much is it going to cost in 91? So in 91, how many more years is that? Well, from 1985 to 91, that's going to be 6 years. Plus, how much did it already cost, which was $620. And so let's see what that gives us. So we have 38 times 6 plus 620. And that's going to give us $848. So we see we get answer choice B. Now this is just one way that we could work out this problem. There's a couple of different ways. This was just an algebraic approach to the problem. Okay, for number 6, the square root of a certain number is approximately 9.2 blah blah blah. The certain number is between what two integers? Well, if it's 9 point something, let's think about, well, what can I take the square root of and get 9? And then what can I take the square root of and get 10? Well, because then that would help us because this number is between 9 and 10. So what can I take the square root of and get 9? Well, the square root of 81. And then the square root of 100 is going to give us 10. So let's see. So that certain number is probably going to have to be between 81 and 99. So number 6, you should get answer choice K. Okay, moving on to our next set of problems. Let's see. Number 7, good old probability problem. So a bag contains 10 pieces of flavored candy. We have 4 lemon, 3 strawberry, 2 grape, 1 cherry. One piece of candy will be randomly picked from the bag. What is the probability that the candy picked is not grape? So the probability of not grape means that we're getting the probability of every part but grape. Well, each probability has to add up to be a 1. So what I can say is I'm going to take all the possibilities, which is going to equal the number 1, and I'm going to subtract the probability of not grape. That's what I'm going to do. So, well, probability of grape. Sorry. Let's change that. That was a, oh dang. All right, so we need 1 minus the probability of grape. I do apologize. So, and then that's going to give us the probability of not grape, because that's the only thing we want to not happen. So we're going to do 1 minus, and probability is what I want over the total amount. We're told that there's a total of 10 pieces of candy in the bag. And how many grape do we have? 2 grape. So it looks like I have 1 minus 2 over 10, which is probably going to give me 8 over 10. And 8 over 10 is going to reduce to be 4/5. So it looks like number 7 should be answer choice E. Okay, moving on to our next set of problems. Okay, number 8. So we have the points A and B, -3, 4, and those are graphed in standard, graphed in the coordinate plane below. And what do they want us to do? The midpoint of AB is 1, 2. What will be the coordinates of A? And most students here, they'll go through and just do a graph and count off, which is nothing's wrong with that. So let's see what we're going to get if we choose to do that. So point B is -3, 1, 2, 3, and up 1, 2, 3, 4, -3, 4. And let's see, the midpoint of AB would be 1, 2. So I'm going to go over 1, up 1, 2. So here's the midpoint, 1, 2. There's my midpoint. And here's my starting point, which was -3, 4. So let's see, how in the world did I change 1 to -3? Well, I go back 1, 2, 3, 4. So I got to go to the right, 1, 2, 3, 4. And that looks like that's going to put us at 5, isn't it? So automatically we can go ahead and look through our answer choices. And number 8, notice that's the only one that has 5 as an x coordinate. So my answer choice has to be K. And I know that sounds weird being that quick, because I know we have a midpoint formula, but if they're giving us the graph and the grid, all we have to do is really count off and see. Okay, so let's look at question 9. Andrea manages a company that currently has 116 customers, which is 8 more than, oh, don't you love these problems, 8 more than twice the number of customers the company had 1 year ago. So it's 8 more than twice the number of customers they had a year ago. How many customers did they have 1 year ago? Well, again, what was 8 more than twice this number? Well, that was 116, wasn't it? So here we can go through and solve this algebraically. Let's see, that's going to give me 108. So it looks like the number of customers they had last year was 54. So number 9 looks like it should be answer choice B. Okay, let's move on to the next question. Number 10. Joseph will have a 200-foot long fence installed in his yard. The A Plus Fence Company charges a $500 fee plus, okay, so I know automatically they're probably going to ask us how much, blah, blah, blah. So automatically I know they're charging us $500 fee plus a set amount per foot of fence. the A Plus Fence Company has given Joseph an estimate of $2,200 to install the fence around his yard. What is the set amount of foot per fence? So if that's his total amount, now we need to take off this initial fee. So we have 2,200, and I'm going to take off this 500 initial fee. So it looks like we're going to have 1,700 left. And let's see, how long of the fence? Joseph will have a 200-foot long fence. So I need to take that 1,700 and I need to divide it by 200, and I can chop off my zeros. And so let's see, 2 will go into 17. Oh, how many times will that go? 6, 7, 8 times 2 is 16. So 8 looks like 8.5 or 850. So number 10 should be answer choice H. Okay, number 11. Okay, this is a great area and perimeter problem. And we are looking at, let's see, reported the area of her rectangular living room. So her rectangular living room, well, if we draw a rectangle, and let's think about this, the area is going to be her length times her width. So we have the length and we have the width of the living room. And we know the length times the width is equal to 180. Well, okay. And then notice that we have the perimeter is 54 feet. And the perimeter formula, let's see, the perimeter is 2 times the length plus 2 times the width. So we also know that 54 is equal to 2L plus 2W. Now I would automatically on this side divide everything through by 2, so we don't have to worry about working that out. So 54 divided by 2, that's going to give me 27 equals length plus width. So we have to think about, well, what can I multiply together that gives me a 180 and then add to give us 27. And if we look at our answer choices down through here, well, let's see, 9 plus 20, that's not going to give us 27. And let's see, 10 plus 18, that's not going to give us 27. 14 plus 13 will, 12 plus 15 will, 16 plus 11 will. So now we need to multiply these and see, well, what can I multiply? Which one of those answer choices can I multiply and get 180? And so it looks like the only choice that's going to be, because we have a 0 at the end, then we know the last numbers has to be a 2 or a 5. So it's going to have to be answer choice C. Okay, now let's look at number 12. And there's always this type of problem on the ACT. So a lot of times people tend to skip it. Don't skip it. Read through it. See what we can do with it. And notice that something that I feel like should be important for us to know is that this is a linear relationship. So my change, I have a rate of change, and it is a constant rate of change. So that tends to make things a little bit easier when we're working this out. And let's see, what is this question going to ask us? Jeremy has $10 in quarters to spend on candy. Oh my. What is the maximum number of quarters he would have left after paying for a box of 25 candies at Tamika's treat shop? So Tamika's treat shop, 25 candies. Well, let's see, 25 candies and Tamika. So we're looking at $4.25. So $4.25. And so we've got $10 worth of quarters here. So my goodness, well, we're probably going to have to say, he's just buying one box, so what is $10 minus $4.25? So that's probably going to be $5.75. And then we need to divide 575 by 25 cents. And so let's see, we would have to move our decimal twice and move our decimal twice, or we could really just go ahead and divide in our calculators. So we have $5.75, and we're going to divide that by 25 cents. And so it looks like he's going to have 23 quarters left. So question 12 should be answer choice J. All right, and number 13, at Tamika's treat shop, what is the average price per candy in a box of 20 to the nearest penny? So let's go see, well, how much? 20 in Tamika's treat shop would be $3.75 if we read our chart. So I have $3. And what did we say? 75 cents, I think. Let me go back and look. $3.75, yep. And so 20 candies, box of 20. So we're going to divide this by 20. And so we can type that in our calculators and see what we get. It's amazing what calculators can do for us. So it looks like I get 18, let's see, 0.1875. And so we need to the nearest penny, so we would have to round this 18 up to a 19. So 13 is answer choice B. All right, and now let's look and see. For number 14, which of the following equations gives the relationship between the price in dollars? So we need the price in dollars, and that's C. So all of the C is price. Okay, so that's important to know. C is price. And the number of candies in the box of candies at Carrie's chocolate shop. Okay, so we need to go back and look at Carrie's chocolate shop. Well, let's see, how much are the candies? Well, let's see, goodness, it might be good to see how much we were spending per candy. Let's see, so for Carrie's, we have a box of candy. Let's see, 5 candies is $1.50. So that's a good starting point. And then notice we went up to 10 is to 50. So let's see if we can figure out the rate of change here. So I know 5 is $1.50. And I think of this as an ordered pair. And then I know 10 is $2.50. So let's see, well, what is the rate of change here? And the rate of change, we would need to go through and subtract what I would call our y coordinates, even though it's not really y here. But we would say 250 minus $1.50, and that's going to be over 10 minus 5. So 250 minus 150, well, that's just $1, isn't it? Over, and let's see, 5 cents or 5, so that's going to give me 20 cents. That's how this is changing each time. That's going to be how much we have per piece of candy, so to speak. So notice that N was the number of candies in the box, and so really all I have to do is look for, well, what has 0.20 associated with N, and that's going to be answer choice F. We don't even have to finish that problem once we find that. Okay, number 15, a good old algebra problem. It asks us which of the following is a solution to this equation. Now, you're always welcome, if it's just wanting you to find the solution, You're always welcome just to plug in your answer choices. However, the algebra side of this one would be a little bit easier. Notice you have x squared minus 36x. X is a common factor here, so I'm going to factor out x. And then notice I have x minus 36 equals 0. So notice that my two answers, one of them would be x equals 0, or, and if I said x minus 36 equal to 0, then notice that I get x to be 36. So which of these two could I find over here? Looks like it's going to be answer choice B. Okay, moving on to number 16. In the figure below, the vertices D and F lie on the line DEF. All right, DEF lie on, the triangle DEF lie on the line CG. And let's see, so, and they tell us a few measures, and it wants to know, well, what is the measure of DEF? So I need to know that measure right there. Well, the way this is set up, we know from here to here is 180 degrees. So if I know this portion right here is 40, then I know that portion right there, 140, this has to be 40. And the same is true for this over here. Well, if I know all the way around is 180, well, what is 180 minus 148? And it looks like that's going to be 32, isn't it? So now the sum of the inside of all the triangle, or the angles in a triangle, has to also be 180. So if I add 32 and 40, notice that gives me 72. So what is 180 minus 72? Well, let's see. If you stinky at subtracting, well, you know that's going to have to be an 8. So that gets rid of the rest of that. And let's see, we had to borrow. So it looks like we're going to get 108, isn't it? So that's going to be answer choice J. Okay, number 17, moving on to 17. Let's see, what are we given here? A company ships notepads in a rectangular box that each have inside dimensions measuring 9 inches long, 9 inches wide, and 12 inches tall. So we've got the dimensions, rectangular boxes, so we've got these dimensions, don't we? So we have a 9 by 9 by 12. Each notepad is in the shape of a cube, and so the cube has a side length of 3. Now a cube would be 3 times 3 times 3. And let's see, what is the maximum number of notepads that will fit in a closed box? So really it looks like I need to take these dimensions and divide each other. Since this is all multiplication, you can very quickly cancel here and get 3. I can cancel here and get 3. I can cancel here and get 4. So notice I get 3 times 3 times 4, which is going to be 36. So 17 should be answer choice E. Okay, looking at number 18, this problem is just a plug-in problem. Everywhere we see an x, I need to change it to -4. And of course, they have some negatives out here to try to mess us up. So we do have to be careful with this. So f at -4 equals -4 times. Now, if you are all about typing this in your calculator, which nothing is wrong with that, you have to put in your parentheses, because if you don't, you are going to miss a sign and it's going to mess up your answer. So do what I did here, and if you type it exactly like how you see it written, then you should be okay as far as getting the right answer. And don't be scared to do your exponents on your calculators. A lot of times students are concerned about doing that, but don't be. So again, I encourage you to use those parentheses. And it looks like when you type all this in, you should get 190 2. So for number 18, you should have answer choice J. All right, so for 19, which of the following XY pairs is a solution for the system of equations? Now, with this, I'm all about you plug in, plug in, plug in, but make sure the answer choices that you plug in works for both of these equations. Because sometimes the ordered pair will work for one of the equations and not the other. It has to be a shared point for both of these lines. So glancing at our answer choices, to me, E looks like it would be the easiest to plug in. So if we plug in E, that means X is 4 and Y is 0. And we can do that in our head. If we look over, well, X is 4, Y is 0. Well, that works for this first one. So it works for the first one. Now let's check the second one. If we plug in, we get negative 8 plus 0. That's not 7, so E is not going to work. Let's see, I would try D, 2, 1. So that means now we're going to try X to be 2, Y to be 1. It looks like it works on the first question again because I'm going to get 2 plus 2. What about on the second one? I get negative 4 plus 1. Yeah, that's not, so it's not D. And I'm just going to skip these decimals. Let's try A. So for A, let's see, and I'm going to erase some of this so I'll have some room here. So for A, I'm going to try negative 2 and 3. So negative 2 and 3. So negative 2 plus 2 times 3, 6. So yeah, that's 4. And then what about over here? Well, negative 2 times negative 2 is 4 plus 3. That is 7. So there's the solution. It's going to be A. But notice you have to be careful with this. I would pick the easiest ones it looks like to work with. But at the same time, you have to make sure those points work for both lines, not just the first one that you come to. So be careful with that. All right, now logarithms. What this logarithm says, you have log base x of 36 equals 2. What this means is x, this x right here raised to some power 2, has to be equal to 36. That's what this means. X squared, or what number squared, because there was a 2 over here, has to be 36. And from our answer choices, the only number over here squared that gives me 36 is G. Okay, now let's look at 21. 21. A 5 by 7 inch photograph was cut to fit exactly into a 4 by 6 frame. What is the area in square inches of the part of the photograph that was cut off? Well, you have a couple of ways you could do this. One way, and since it's asking for, well, what is the area? Well, what was the area of the 5 by 7? That area was 35. And the area of the 4 by 6 was 24. So the area that was cut off, if we subtract those two, looks like the area was going to be 11. So 21 looks like it should be answer choice C. Okay, now let's look at 22. And it looks like 22, we might have to draw a picture with it. So let's see. A line, it contains points A, B, C, and D. Okay, so I'm just going to draw me a good old line here. Let's see, and point B is between points A and C, and D is between points C and B. Oh, me. Okay, so let's see. So point B is between A and C. So I say A is here. If C is here, then that means that point B is between them. So point B has to be here. And then it says point D is between C and B. Well, between C and B, well, then that means point D has to be somewhere here. So which of the following inequalities must be true about these segments? Well, this is just fantastic. So let's see. BC is longer than AB. So let's see. BC is longer than AB. I don't think so. Unless we've drawn this problem, I don't think that's the case. So let's try something else. Let's go to a different color maybe. So the next one says BD. So BD is what? Is smaller than AB. Well, who the heck knows? I don't think we can make that statement. Okay, so let's go on to H says BD. So BD is smaller than CD. Nope, don't think so. Let's see, what about CD? CD is smaller than AB. Okay, and then let's see, gosh, CD is smaller than BC. Oh, now that might be true. Let's see. Let's look at this again. Because these two were like, well, CD, if we talk about CD, is smaller than AB. Well, we don't know still. There's no for sure. I'm not sure about that. But let's look at CD. CD is smaller than BC. Well, yeah. Now that one we could say is true because we know D is between B and C, right? D was between B and C. And then we also, yeah. So that would make sense. That one, yeah, we can do. So that one is a for sure statement that we could work with. So that one would be a good one. Okay. All right, let's move on to the next set. All right, number 23. Number 23. We have x and y are positive integers such that the greatest common factor of x squared y squared and xy cubed is 45. Which of the following could y equal? So we've got to think about common factors here. Well, if we have an x squared, let's talk about this. We've got x squared, y squared, and then I have an xy cubed. Okay, and so what I need to do to get the GCF is between, let's undo that last line there. So between these two, well, let's see, the GCF, greatest common factor, both of them have an x, so you pick the one with the smaller exponent. So greatest common factor, biggest exponent or smallest exponent here would be x. And then what about between the y's? It looks like it would be y squared, doesn't it? And so it says the greatest common factor is 45. So I know xy squared is 45. So which one of the following could y possibly equal? Well, y can't be 45 because that's 45 squared. Couldn't be 15. Now we're tempted to say it's 9, but remember, you're looking for y, and you know that's y squared. So if I plug in 9, that's going to give me 9 squared, which is way bigger than 45. So then hopefully that sees that we need to jump down here to E. So 23, hopefully you got E for that one. Okay, looking at number 24. Oh my goodness, what a terrible problem 24 is. So, goodness, we have each 300 volunteers was assigned a distinct number. Next, a calculator was used to simulate the drawing of 150 balls from among the 300 congruent. Oh my gracious. Okay, the balls were numbered the same way so that 150 volunteers to receive the new medication would be chosen without bias. The other volunteers received a placebo. Weeks later, two groups were compared. Which of the following phrases best describe the company's testing? Oh, goodness. I would say it's definitely some kind of randomized, right? Because they went through all that trouble of making sure. So I would omit the non-rip. And let's see. Really wasn't much of a survey or a census here. I think it was more of an experiment, so it would be answer choice G. Okay, so let's see, and that one, there wasn't much math to it. It was more or less just frustrating to read through the paragraph. Okay, so now let's look at 25. Let's get back to some math. Okay, now for number 25, let's see what we have here. So it looks like we have a caution light, and this caution light flashes every 4 seconds. And then there's another caution light, and it also flashes, but it's every 10 seconds. And at a certain instant, the two signs flash at the same time. How many seconds elapse until the two signs next flash at the same time? Well, okay. So let's see. Let's list out, and hopefully we can see what's going on here. Let's see. So 4 seconds. And then after 4 more seconds, we would do, let's see, 8. And then 12, right? And then 16. And then 20. And then, let's see, for every 10 seconds, it would be 10, and then it would be 20. So notice how many seconds elapse before the next two. Well, let's see, how many seconds have elapsed here? Let's see, 1, 2, 3, 4, 5, right? So 5 times 4 seconds each. So it looks like we're going to have here at D. Okay, now on to number 26. In number 26, we have for all non-zero values of A and B, the value of which of the following expressions is always negative. So always negative no matter what. Well, that's kind of hard to pinpoint really, because we're used to seeing that absolute value of any value A is always positive. Now we might have a negative stuck out here, and let's go ahead and write positive A. Now if I have a negative stuck out here, we still do the absolute value of A, which is going to be positive, but this negative means the opposite of positive A, which is negative A. So now we don't know for sure values for A and B. So as far as F and G, we don't know. And some people like to argue a case for G, but if B was a negative, we would have minus a negative, which becomes positive, and B could certainly be then larger than A, and we would get a positive answer. So let's see. H would always be a positive, so we're looking for always negative. J could possibly be negative, but it doesn't have to be. So that only leaves us with option K, or our reasoning is wrong. But again, this is going to generate a negative A. That's going to generate a negative B. So no matter what those numbers are, this will generate a negative answer. So 26 should be answer choice K. All right, number 27. Let's see. Graphed in the same standard XY coordinate plane. What are we given? We have a circle and a parabola. And a parabola, when you graph it, is a U. The circle has a radius of 3 and is centered at 0, 0. So what that means is our radius is 3, so we go out to 3, up 3, back 3, down 3. So we have a good circle here with a radius of 3. And we have now a vertex, probably with a vertex of -3, -2. So we go back -3 and down 2. So there's our vertex. And we have a vertical axis of symmetry, so that means that we're either turned up or turned down. And passes through the point, let's see, -2, -1. So -2. So we're going to go back to -2, 1, 2, and then down -1. So that tells us that our parabola is going to have to be turned upward because we have a vertical axis of symmetry. We have our vertex. We're going through that point. And so the question says, the circle and the parabola intersect at how many points? Well, let's connect our dots and see. Well, it's not going to happen over here, but notice over here, we have to intersect at least 1, 2 times. So my answer choice is C. Okay, so now let's look at number 28. Number 28 asks us to find, well, 40% of 250 is. So I would start out by finding, well, what is 40%? So 0.4 of 250, well, that's going to be 100, isn't it? So 40% of 250 is 100. So 100 is equal to 60% of what number? So we need to find 60% of our answer choices. So really, we could very quickly go through here and multiply every one of those answer choices by 60%. So in other words, 150 times 0.6. Let's see, what does that give us? That's going to give us 90. So that's close. So we need to be bigger than 150. So let's try 160. So 160 times 0.6, that's going to give us 96. So if that's 100, or I'm sorry, if this is 90, that wasn't 100, or it would be our answer, right? That's kind of crazy. Let's see, where did my eraser go? There it is. So we said that this was 90. This was 96. So I bet answer choice H would have to be the correct answer. Now we can multiply it out, but again, trying to save us some time here on the ACT, so I don't know if I would multiply all that out. Okay, let's move on to 29. And 29, which of the following inequalities is equivalent to? And notice they solved for x. So let's solve that bad boy for x. The biggest thing with inequalities that we need to remember is if we multiply or divide by a negative, our inequality has to change directions. And that's usually where students miss this. We're solving just for x, so let's add 6y over. So I have negative 2x is greater than 8y. And then we still have our minus 4. And automatically, I know I'm going to divide by negative 2, so I'm going to flip my inequality. And then I'm going to look at my answer choices and get rid of B. And I'm going to get rid of E right then. And then what is 8 divided by negative 2 is negative 4y. And I'd go back to my answer choices and notice there's no other negative 4y, so A would have to be my answer choice. Right, so let's look at number 30. And number 30, for an angle with measure alpha in a right triangle, sine of alpha is that. Oh, we got to find, okay, well think about some old hippie caught another hippie, and that's an H. And we say tripping on acid. or you could say SSCC, either one. So if I'm given a ratio, if I'm told that sine of alpha is 40 over 41, that means I know the hypotenuse of my triangle. And then let's think about this. Well, and I also know the opposite side. So I'm looking for cosine. So cosine is adjacent over hypotenuse. So I need this hypotenuse to be 41. So let's look at our answer choices because we already have a piece of it. And hot dog, the only one that has a denominator of 41 is F. Now, not all of them would be that easy, so I would go ahead and finish out this problem just for explanation purposes. But if it does happen to be that easy, circle it and go on. You're also told that tangent of alpha is 40 over 9. And remember, tangent is opposite over adjacent. So you have opposite and you have adjacent here. And so there's your adjacent value. So A would be 9. So that's how you can use those trig ratios. I'm going to stop the video here. That is the first half of the practice test. And then I will load the second half.